Hello, hi Michael. Good morning, good afternoon, good evening, everybody. Thank you for joining. And yeah, welcome. Hi Michael, how's it going? How are you doing?
It's going well. Had a good weekend. Went to see some family, little
Nice.
baby, and that was good. And took long walks in the park, and that was good as well. So enjoyed myself. And we had a day off on Friday. So the
Yes.
company had a company holiday,
Yeah,
which was really great. So spent some time
exactly.
cycling and going swimming. What
Okay,
did
so I
you
hear
do
your
for
weather was
for the
better. The
company?
weather here was mixed, I'd say. On Friday, I was in the city and walking, meeting friends, and Saturday it rained, and Sunday it rained also. Went to the museum yesterday though, so
Oh, nice.
yeah,
That's a good one.
yeah.
Super.
So that was good.
Yeah.
Yeah, I think it's gonna be like in the title. It's also it says it's part two of the podcast data we
Yeah.
explored last week. Before we do that, I want to do one more time
Yeah.
because on Wednesday is actually the final day
Yep.
when you can submit. So notes call for papers is open. We have received a good number of submissions so far, but you have basically 3 more days, including today,
Last
um,
chance. Exactly.
to submit something. So if you have anything of interest you would like to submit, this is your almost final reminder. I'll do one more stream tomorrow, Neo4j live tomorrow afternoon, and then you're on your own. No more reminders,
Yeah.
at least not in the part of the stream. So yeah,
At
please
least not for
submit.
call for papers, right? So we
Exactly,
still want
exactly.
you to
We'll
attend.
continue right after for registration.
And actually,
Exactly.
we were thinking about doing some streams with some of the speakers and perhaps having them explain what they're trying to present or what they're going to present, and see if you can have some fun discussions. And so that would be like leading
Yes.
up to notes. I think that would
Yeah.
be some fun streams actually
Exactly.
to go beyond.
I think
Yeah,
so too. That should be
that's
good. So looking forward to that. And yeah, if you want to submit something, do it. No matter the level and whatever the topic. Really, it's a all-purpose, all level event. So anything works.
yeah.
I'm pretty sure. So yeah, I don't think I have to go all the way over from what we did last time. So I think maybe we do a short recap of what we did last time instead of what
Yep.
AuraDB free is instead,
I think that's a good idea. Yeah.
versus all of this. So you know this, so I guess we can skip it. So maybe let's look at what we did last time to catch everybody up that didn't watch the episode. Um, so I think,
Exactly.
yeah, in general, there we were looking at podcast data. So we had thought about what what's a podcast, obviously, and how can you use the data in Neo4j. And
Yeah.
Michael found this website called Player FM, where they don't necessarily have an API, but they have
Yeah, a
a
sneaky way
way
that they
to
even
a
point
sneaky
out in
way. Yeah,
their
yeah,
FAQ, right? Uh, so you can get
exactly.
the JSON for many pages, but unfortunately not for the overview page, which is really unfortunate. So we had to play some games to get a number of podcasts to start with, but then each podcast has actually a JSON page and each episode as well.
Yeah,
So as soon as you have a podcast URL, you can basically dive into getting the data, but you first have to get the podcast URL to start with.
yeah.
Exactly. And so
So
we
we
looked
looked at
at kind of what's the
yeah.
structure of a podcast, right? So I mean, if we perhaps that's a good thing to recap actually,
Yes.
as if we go into something like Arrow or Data Importer. So we have our podcast as the base element, right? And then of course we have someone who hosts the podcast, right? So a host, and they host the podcast as such. And then the other thing that PlayFM also provides for each podcast is tags. So we have also tags for each podcast, which will become more interesting today actually than last time. So we had something like tag. And so a podcast is tagged with tags. And then, of course, a podcast has a title and a length and a description and so on. And the other thing that we also fetched from the data was the episodes of a podcast. So if you take an individual podcast with all details, I think this was the full detail one. Then for each, so you already see it's also much longer, the file. It has also episodes list, and then for each episode, basically, you again get an ID, you get an slug, and so on. So which is a description,
A description, exactly,
and
image.
so basically also each also podcast has published an episode. So if you go here, episode, and the podcast has published an episode. That's so published. That's kind of roughly the data model that we ended up with. Unfortunately, something like guests or links or episode show notes are not really in this API, which is unfortunate because that would be really interesting, kind of who's being guest on which shows
Yeah.
and what are they talking about. So as you probably know, each podcast. So for instance, if you look at 99PI, the one that we just looked at, where is it? Oh, here, 99PI. If you look at the episodes in the real episode home, uh, then they actually have a lot of show notes as well, right? So they have description, more
Ah, okay, yeah,
information,
yeah.
the host, the title, basically credits, and usually also have show notes. So if you go to anything on the podcast platforms, they're usually linked to things they talked about and so on. And it would be nice if PlayFM had this in their API as well, but unfortunately neither the guests nor the topics of the episode or the URLs, sorry, for the show notes are not in there, unfortunately. So we need to basically use what we have. We could, of course, if you wanted to, or if someone wanted to, you could go to each podcast site and fetch additional data as well, but that gets more complicated because each podcast hosting platform has different formats and things like that. So it's probably something you would do when you really want to build a podcasting API, which is probably a
Yeah,
little bit
that's
outside of the of our
yeah,
scope.
that exactly. I think this is
Right.
beyond, because I mean, you can do this for your maybe if you build this for yourself and have, I don't know, 50, 100 podcasts you have on
Yeah.
subscription, and you want to know more about these and have a better view on episodes and everything else. But imagine how many podcasts are there? A couple of million probably.
Yeah, I think here they
So
say 20 million
20
podcasts, right? So
million.
that's
So
a lot of
yeah,
data, right? So
I mean, all of them have their own individual websites. This is
yeah, exactly. It gets a little bit too much. But
yeah,
we could get the data that we showed you, and
yeah.
what I did as a preparation for the episode, because as I said, you can append .json on an individual podcast and also get the full episodes on of a podcast. But something like if I go to the like all the topics or something like that, right? So if I go to this topics page here, which has all the podcasts, especially if you switch to list mode, then you have like this all the podcasts. But if I append .json to this page, I only get like a minimal page that has like that's all on this page, right, for
Mm,
JSON, right? So it's kind
yeah,
of useless from that
that
perspective.
is a bit useless
And
indeed. Yeah.
um, so what I did in preparation of today's session, I actually have this somewhere over here. Yep. I just scrolled all the way to the bottom of this page, which is like endless scroll, and then saved the HTML and extracted all the podcasts from this page, which were then like 2,300 popular podcasts, basically.
Oh, okay.
Right. So, and I just did a regular expression basically on top of the, I can show you actually. Here, I just basically did a regular expression on top of the HTML, which extracted all the topics, and then I sorted and deduplicated it, and now we have a list of podcast URLs of 2,395 podcast URLs, which is a good starting point for us to import some of the other podcasts
Okay. Yeah.
as such, right?
Mhm.
So that's what I did in preparation. And I started to import some of them because it takes a little bit of time to import them, and I didn't want you basically to wait for us watching us importing podcasts. But this is actually quite nice because it gives us a good starting point to look at a little bit at the structure and data and tags and hosts and so on. The other thing to recap is kind of how we imported the data. So we did two things last time. So we had this individual podcast. So we started out by grabbing just an individual podcast, like here, invisible, 99% invisible, added a .json at the end. And here you see we have things like URL, the author of the podcast, title of the podcast itself, podcast home, slug for the podcast as well, and a few tags too, right? So the tags are kind of really weird because the raw title is kind of cut off and misses letters and so on. I'm not really sure what they use it for. So we went for the full title of the tag as
Yeah.
well, and that's what we imported as the base information, right? And something like how long the episode, how many episodes the podcast has as well, and that's what we mostly looked at, right? So this was our first part of the import, which is basically, if you look at the data model, it's basically the top of this, right? So the
Yeah.
podcast, the host, and the tags.
Do you want to
And
quickly
we
show this
loaded
in the browser?
exactly. That's what I just wanted to do. And we basically loaded this data. So it's basically this here. Let me just show you this one. So we basically use this URL from the podcast. So we can basically grab this URL, put it in here, and then we use a procedure called epoch load JSON, which basically does a web request to a web API or web page or whatever, and fetches the JSON. And whatever it returns is basically the same structure that you just saw in the web browser, which is basically all this information that we just looked at, right? And what we can then do in Cypher is basically take this information and turn it into nodes and relationships. So what we first do is we take some of the values or the entries or the keys of the resulting JSON, so like description, language, title, ID, author, home, then the number of episodes from the stats sub entry, put it on the episodes, and take this as data. And then we go over all the tags in this value thing and grab the title and the ID of the tag as such. And so that's kind of what we extract as data from the JSON. And then we use our data to create our nodes and relationships. That means in the original code that I had here, I basically had a merge p podcast and then slug is value dot slug, something like this. And then we basically took, as you can see here in our JSON, there's a slug somewhere here. So we basically, this is our unique key in the database. And that's what we merge the podcast on. So that means merge is get or create. So if the podcast already exists, we just get it back from the database. If it's not there, then it would create a new one and set this ID property on the podcast. And then we add all the additional data that we extracted from the JSON as attributes. So description, language, title, author, ID, number of episodes, and the home. And then, so if you look at a few of our podcasts here in our graph, you see all of these things also set as attributes, right? Number of episodes, description, author, home, ID, language, slug, and title, right?
Yeah.
And then, as the next thing, we take the tags that we extracted here. So for each tag, we took the title and ID. So if you remember, in our tag, we have basically title is here and ID is here. So we basically just iterate over them and extract these things. We didn't figure out what the amount and centile actually means. If
Yeah.
anyone knows, please let us know. But otherwise, we basically just extracted the tag and the title from this and then use that for our data creation. And so this is a list of tag and title pairs, basically. And then for each, we take this list, unwind this list into rows. And then for each of them, we basically create a tag with the ID and set the title as tag name. So we have now a lot of tags in our database, which has all gotten an ID and a name as well, right? And because we merge ID, it's basically unique, even if the spelling is perhaps the two different podcasters, so it should be unique. And so we look at a larger volume of data a little bit later. So because I imported more of this today than last time earlier, so it would be interesting how much we actually got. And then as the last thing is sometimes the author is not set in the podcast. So we basically just get our podcast in our data field and we say when we have an author, so where the author is not null, then we also create a host node here and say the host hosts the podcast, right? So for instance, if you look at our hosts here, we can basically say, here's for instance Roman Mars and he hosts twice 99% invisible because I think one had the slug forward different. So one is this. So it seems they have also inconsistency in their data, right? So once they have line 99 invisible as the slug, and 199 spelled out, right? So that's
Yeah.
why we have two entries here. Or if you have someone else here, they also host one podcast, right? So we can also look at who is hosting many podcasts and things like that as well. At least in the popular 3000 that we're importing. Exactly. So that's our basic thing that we imported, and then we went a little bit further last time, where we said we want to also. There's also like additional URL parameters where you get full information of a podcast, including all the episodes. And so we had another script that basically. Let me just fetch this with history. So there's a really cool feature in Neo4j browser called history, which gives you all the past things that you ran. So, and if you scroll down, somewhere here should be episodes. Where did we import the episodes? Somewhere here, host. Here's an episode. So where you see here we pull the whole data from the podcast as well with all the details. And then we basically get the episode information. And then for each episode, we get the title, duration, ID, description, slug when it's published. And then we find some of those podcasts have a lot of episodes, right? So I'm listening to some that have oops, something happened to my screen. Can you still see it, Alex?
I can still see it. Yeah, I think it looks like we briefly lost your.
It just interrupted for a second, so
But
sorry
you
for
should
that.
be back. Yeah, no, it's good.
Okay. So we take all this data for an episode, and then we find the podcast by ID, and then we basically go all the episodes and create an episode note for each of those episodes and connect to the podcast as well, right? And that's basically the basis of what we did last year, and then we looked a little bit at the data that we had as such, right?
Yep.
Cool. And today, so we said, okay, last time we spent most of the time with like data importing and not so much looking at the data. And today we thought it would be cool to have a part two where we also look a little bit at the data as well and see what can we do in terms of like correlating information, but also looking at who is very prolific as an podcast. And for some reason, my computer keeps redoing the screen thing. So I'll just 1 second.
Maybe, yeah.
Let me just try this. Hopefully this is going better now. So I just updated my mirroring device and probably that broke it or something like that. So never do updates of things when you
Yes.
just before a live stream.
Yeah.
Haven't learned from the haven't learned from the past. Um, so I thought what would be nice is basically to do the same, but look a little bit at the like overall structure of the podcast universe as such, right? So not dive deep into an individual podcast and the episodes. We could do with the podcasts themselves actually is um, we could run some NLP on the descriptions and episode descriptions. So we could extract something like topics or people or things like that from descriptions and episode descriptions, but I haven't done that yet. Could be probably something for a part 3 sometime. Or perhaps homework. So if you're interested in that, perhaps then doing the doing the NLP on the text could be something to do, and let us know if you do
Yeah.
it and get some good results. But what I wanted to do is look a little bit more at the higher level structure of the podcast universe as such. And, uh, so what we have now in here, so what I did is, as I said before, I basically took the titles from the, I can show you, it's probably easier here. Um, if you look at this, so this is kind of 3,000 lines of URLs from podcasts as such, right?
Hmm.
So quite a lot. And what I did, I put it on GitHub. So there's in the GitHub repository that we shared also last time, there's also now a file with all these podcast URLs. Actually, it's just a plain file, so it's not ASCII-Doc or something like that.
Hmm.
So I should probably be able to disable this. Does it disable this? No, for whatever reason, it doesn't disable it. Anyway, so this is just in file with URLs, right? So the same that you saw, and I just put it on GitHub so we can load it into Neo4j. And then I basically just load it into Neo4j, the file somewhere really simple here. I basically did this. I loaded the file, took each row, removed the player FM prefix as slug, and then created a podcast entry for each of them. So basically, I loaded the file, and this is actually size of. So you see, this is kind of what I got back from the file, and then I basically, for each of those entries, I created an podcast entry here. So that's why we have now also a lot of podcasts in here.
Okay.
And those started out having only a slug. So I can basically say how many podcasts do we have now in our database. Let's see. So we have now 3,200 podcasts in our database. So that's the ones that we did last time, plus the
ones.
almost 3,000 that I did today. And then basically, I fetched all the podcasts that don't have a title yet. That they have a slug, but they don't have a title.
Hmm.
And then basically reached out to the URL with the JSON at the end and did the same that we did last time. Basically, fetch the additional data, connect to the author, and the text as well. So if I run this, it will basically create 10 podcasts, or for 10 podcasts, it will fetch all the additional data. So for these, we should now have basically tags and an author as well, right? Or
Nice.
7,
Okay.
actually. Yeah, right. So it just fetched 7 also. So we have now more of this kind of data. And so I did this basically for all 3,000 podcasts,
Hmm.
which took a little bit, but actually it's not too bad. So actually to show you how long this takes, let's see, let's take this one here. So I basically just take 500 podcasts at a time and do the load, and then basically I do it in batches of 100 transactions, because this is AuraDB free, so we can't use up all memory here. And basically it does the same as I just explained, right? So fetches the information for the podcast, the tags, and the host, and then just batches this up in 100 rows at a time. I also threw in epoch util sleep to not overload the API and not be banned or throttled or something like that. So it sleeps for 10 milliseconds between each request, basically, as such. So so this would fetch now. There's I think 300 podcasts left that don't have a title. So I did all the other ones. So it basically will now reach out and fetch the data from the API. And now the server doesn't like us anymore because we probably fetch too much data, or I fetch too much data as such. But fortunately, it allowed us to get through all the rest, and so from that perspective, it's not a big deal. So we got all the other things.
Okay. Yeah. I mean, that's okay.
So and what we now can look at
It's
actually
not
how much.
necessarily meant for this, I guess. So that's why they probably put
Yeah,
in some
exactly. So
kind of fail-safe or overload
exactly. So we can actually
restrictions.
look at how much data we have in our database of each type. So we can say return the labels of our nodes and the count. And if you look at this, we have 3,000 podcasts, 2,200 hosts, 8,800 tags, and 832 episodes from last time, right?
Hmm.
So that's actually quite nice. And now we can look at the data a little bit. So, and one thing that we could do is basically do it in browser, but perhaps we want to go back to look at the data visually a little bit. And so
Hmm.
we thought about looking at Neo4j query. Sorry, Explore. That's the new name for Bloom. And I just have to fetch the. 1 second.
Yeah, with Bloom, you
The
can be
credentials.
more visual, and we can play around a little bit
Yeah,
with the data as a more visual in a more visual
exactly.
way, and with that we can show it a little bit better, I think,
Exactly.
what there is and how it's connected.
Exactly. And Bloom can also render 10,000 nodes, and so it's nicer
Mm.
to see as well from that
Yeah,
perspective, right?
yeah.
And we can also style and visualize things. So, for instance, if you want to see just let's say, an episode which is part of a podcast which is hosted by a person, so we can just say, go for this and fetch us some of these, and so we see here actually two podcasts that we can look at. So this is 99% invisible that I mentioned last time, and these are like all the episodes that we imported for the podcast as well. And the host is here, the little
Yeah.
purple
This
one,
is what we
right?
did last time when we loaded
Exactly,
a
right.
couple of episodes. Yeah.
So and what we can do here now is basically we can say, okay, we can also pick an icon. So for instance, an episode could be something like an good question. What would you say? Alex, could we use for an
Try
episode?
episode. Maybe there is an icon for that. No, there isn't.
Let's see.
Okay.
I don't think so.
Um, so it's
What's
like
an episode actually? Good question. Let's take the
like this.
via
Okay. Yes.
via the
Yeah.
symbols here. Then
Yeah.
for host, we can. And let's look what text. We should probably use title exactly. For host, we can use a person as an icon,
Yeah.
and as text, we use the name. And for the podcast itself, as an icon, we could use either headphones, right? That could be a good icon.
Yeah, that's a good
Uh,
icon. Yeah.
and then we could use as text as well the title. There's the title of the episode's home. Why is it not showing the title here? Good
Was it home?
question. No, it should be actually title. There should be actually a title on it. And for tag, our icon would be something like a tag, which you usually had in the overview. Here's something, right? Tag, something like this. And our text is the name of the tag, exactly. Um, so and so if we zoom in, we also see like the episodes, and then we would also see the title when you zoomed in enough, or the host name basically as well, right? So for instance, if you want to actually look at hosts which or for instance, let's look at hosts which have multiple podcasts, right? So if you say podcast, host, podcast, that would be a host who has at least two podcasts, right?
Yep.
So we could look at this. Let's see. And this should give us like at least pairs of hosts that host podcasts as such. Okay, so we can probably. Oh, there it is. Right, so that's basically. You see, let me just remove the episodes. Dismiss the episodes. So we have now no episodes. But you see now we have like hosts that have quite a lot of podcasts, right? So there's a host called BBC Radio 4, and of course the
Yeah.
BBC has a
Okay,
lot
they
of
have.
podcasts. But also we have hosts that have at least two here, or here are a number of studios that have multiple podcasts as well, right? So mostly
Yeah.
news organizations, but I think there are also individuals who have more than one podcast as well, right? And so that's one thing that you could look at is kind of how prolific are hosts in this, and you see clusters emerging here. What would be actually interesting is are there like multiple hosts that have podcasts together? So if I basically turn this around and say an host which has a podcast, and then they have a co-host basically, right? So two people hosting the same podcast.
Yeah.
And if we overlay this with the existing data that we have, oh, we don't have multiple hosts. Oh, right. You know why this is? Because in our source data, that's actually a good point. In our source data, there's only a single author field on the podcast itself. So we don't have more than one
Ah.
person in here,
Yeah.
which is
So I
really
never.
unfortunate, right?
Yeah, and they never tag guests and stuff like that, so we never
Yeah, that's
know
really
who is
unfortunate. So
who
we
is
should
part of us.
actually
So
see so this data hopefully I mean they have something like the text and so, right? So they should be able to do this as a like multiple things, right? But it's a little bit unfortunate that there's not multiple authors or guests in here, right? Okay, then perhaps we flip this around and look at tags instead, right? So we can say basically
yeah,
we could say
this we have.
what tags do we have, but also what tags have basically podcasts that have at least two tags or something like that, right? So I guess this will be a lot of data. Let's see.
Oh,
In case we can also limit this to like only 1,000 or something like that. Otherwise, it gets a little bit overwhelming, I think. Let's see. Let's fetch this again with only 1,000 things back. And so this is one way of looking at things. And the other way is, of course, when podcasts share text, which is actually the more interesting bit, right? So a podcast with multiple texts is what we've already seen in data. But what's actually more interesting is when podcasts share text, right? So basically, this is like a dense cloud of podcasts with many tags, as you can see here, right? So some podcasts have probably gathered a lot of
yeah,
tags,
they maybe
basically,
they do
right?
different things every time. Yeah,
Yeah, and if you look at this looks more like like
okay.
late night shopping, right? So where
Yeah,
they basically just overwhelm
sale.
everything with hundreds of pointless tags, right? Like
Yeah,
luxury buy and buy a home, how to sell a house, home sweet home, whatever, right? So it's like crazy. It's also called sold by Marco. It's probably like an real estate agent which puts like his houses on a podcast
yeah,
or so,
maybe it
which
does.
is
Yeah,
which is actually a fun idea if you think about it. But because it's a new way of promoting stuff, right? So
yeah,
so what's more interesting is if podcast share text, right? So if you look at this, then becomes a rather kind of what's the overlap of podcasts, right? So, and this gives us probably very popular texts that are shared by like arts and so on, right?
mm,
Which are shared by a lot of podcasts. Um, so unfortunately, in Bloom, we can't limit this really easily to say I only want to see tags which have, you know, a reasonable or a small number of podcasts, or like I want to see basically podcasts that share as many tags as possible as such. So that's where we need to probably go back to browser, and then we can actually use this information to do some kind of recommendations as such, right?
Doesn't work via the filter.
I mean, you could. We don't have the podcast count on tags, so and the filter currently don't work on degree, so you would have to add an extra degree property on the tag basically. So currently only has ID
yeah,
and
okay.
name, so we would have to add this information.
Yeah. Okay.
But if we had the filter, we could do it, but then we would have to fetch more data and post filter. While what I actually would like to have is basically allow the filter to go into the query as such, right? So that would be quite nice. But what we could do in Bloom is probably do the same with a Cypher query. So perhaps it's a good idea to show how these Cypher queries work actually. So because in Bloom, what we can do is we can over here on the left side in the perspective, we can basically look at nodes and relationships, but what's actually more interesting is the saved Cypher queries, and there are two ones. One is called scene actions, which is running Cypher on selected nodes on the scene, basically. And the other one is search phrases, and we can basically create a new search phrase that says common or tag overlap or something like that, right? So basically return us a bunch of podcasts that have tag overlap. So that means we find tag 1 assigned to a podcast and a tag 2. Oh no, we said it's the other way around. Podcasts that share tags, right? So P1 is a podcast, which is tagged with a tag. And another podcast, P2, is also tagged with the same tag. And then we can basically return P1, P2, T. No, we say count star. How often have these two podcasts been overlapping, basically, as frequency. And then we also take our tags. And then we say where order by frequency descending limit, let's say 50 or something like that. So we get the top 50, and then we return basically all the three. So P1, P2, and the tags. So I hope it also renders relationships because we don't return them as such. But if it doesn't, we can change the search phrase to also return relationships as well. Right.
Yeah.
So that
in
means
this case,
if
we don't
now,
even have a variable we need to pass through.
Yeah, exactly. So we could add a variable like the number or something like that, or we could add a start topic or something like that. And but let's just say tag overlap here and see what happens. How much it fetches. So it should. Yeah, I see it doesn't return the relationship, so we should probably get the relationships after the fact. So we probably want to see how do we do it? We return P1, P2 the tags, and then T in tags. And for each of the T's, we also say basically the pattern P1 has a relationship to T. That's our first rels. Actually, I think it can just return the pattern, and then actually we can probably also do it like this as pass. For all our tags, we basically find the ones that are connected to our podcast, basically. Again. So, and this is basically path. So let's see if this helps. Invalid search phrase. Please check definition of search phrase. Tag overlap. So for all our tags, we find. Oh, sorry, we forgot to spell out paths here. The paths that connect P1 and P2 to the tag as paths, and then we return this. And hopefully you can deal with the nested list. I'm not 100% sure. Let's see.
Let's find out.
Yeah.
Oh, here we go. Nice.
Right. So the yellow ones are the podcasts, and here we see they really have massive overlap here, right? You always see these kind of pairs of podcasts that have massive overlaps in tags with another podcast, right? So they are really close in terms of, you know, covering the same areas, right? So for instance, we might zoom in here a little bit and see, actually, let me see if we can put the title of the podcast now into the, does it now have title? I don't know why it doesn't have title.
Strange.
Can we edit here? Here it has title. But it doesn't show it.
That's strange.
It doesn't show it for the.
Yeah.
That's weird.
That is weird.
Anyway, but so you see there's a fitness podcast here, right? And there's another fitness podcast. Okay, found my fitness. Perhaps that's just two editions of the same podcast. Oh, they seem very similar, like 9 to 5. So this looks almost like the same podcast always, right? Which is a little bit weird. Anthropocene reviewed, and this is also Anthropocene reviewed.
Maybe we need to exclude?
They have different. No, can you see that they have the slugs, ones with an ID and ones without an ID.
Okay.
And another ID. So the slugs seem to be not unique for whatever reason. Okay. So that's another data problem, basically. Mindset Neuro, Mentor. So at least we see that in the same podcast.
Okay, he groups them together. Right. That works well.
Which is really unfortunate. So where we can probably say is where they don't actually share title or something like that, right? So where p1.title is not the same as p2.title, right? So this should at least give us the different podcasts. So let's clear the scene again. Clear scene. And then we try this again one last time. So this is clearly data quality problem, right? So the slug doesn't seem to be unique. So we need to check actually if the IDs are unique of these podcasts or not. And then we basically need to figure out basically how can we do. So this is basically, what is it called? Lens-plotation, and that's the landscape study podcast. I see that these are actually two different ones.
These are different, definitely, yes.
Right, and here's one. This looks actually quite similar. The arts past present for iPad and Mac PC. Okay. Here's a meditation podcast together with a history of Fall of the Roman Empire. All these are both audiobooks and arts, basically, and instructional.
Yeah.
That's interesting. Right. So this is kind of instructional audiobooks over here. And this is something with rabbits and tennis, whatever tennis is. I have no idea.
No idea.
You know what tennis is? I've never heard tennis.
Is that that's a podcast or what? Yeah, probably must be tennis. Tennis.
Okay.
High Weekly Public Radio Alliance. Docu-drama about fascinating and surprising mystery. All right. Well, I don't know what the connection to rabbits is there.
I have no idea. Actually, you can look at our text that I have drama, binge-worthy fiction, storytelling, sci-fi stories, audio drama. This is American Life, NPR Public Radio, true crime. Okay, so it's probably the Rabbit podcast is then also something like
I guess so.
True crime drama thing, right?
Or maybe
But
it's a rabbit
so
that solves crime.
yeah. So, but if we take this information, that's actually something that we can use to find, can we do a recommendation, right? So, for instance, our query could be, we have our podcast number one, which, for instance, shares a host with a second podcast or a tag, right? So, where we say we have a tag between the two podcasts where they are similar, and then we take the two podcasts, P1, P2, comma count star as frequency. So basically the same query that we just had, and collect t as tags, and we again say where p1 dot title is not the same as p2 dot title, because otherwise it would be not so helpful. And then we say order by frequency descending, limit 25. And then we could also say we also want to have the same author for the podcast or something like that, right? That's something that we can actually express here as well. And P1's host also hosts P2 basically, right?
Yeah.
And we just put an axis around this, right? So the host of P1 also hosts P2 hosts, right? So that's an optional criterion, basically, that we could say we want to give it some relevance or not. And then we can actually return p1.title, p2.title. Well, let's do the computation here. And so we just compute what we want, and then we return p1.title, p2.title, and t in tags, and for the tags basically in name, right? So as tags, right? Title. So as frequency, and so this now should give us some. I'm not sure if you have actually an index on title. Create index on podcast title. So, and we should probably put in a tag here as well to have it specify this a little bit more clearly. So, okay. And now we could basically say if we want to limit P1, for instance, to one podcast that I like, for instance, say is 99% invisible. Then hopefully it doesn't return us something. But it could also be that my this one. Yeah,
Yeah,
it should have enough tags.
you added a hyphen 99 invisible without the hyphen.
Yeah, I just wanted to see what the slug is. There is 99
Or is it?
invisible.
Okay,
No, it should actually be.
yeah. Okay. No.
Perhaps it's the host thing that. No. Podcast 1 is tagged with tag. Podcast 2 is tagged with tag. P1 slug. In will see. I missed an E.
Oh.
So
here we go.
right. So here I would see there's other podcasts about like arts and graphics and design that basically could be interesting, like Architecture Today or Gastropod or things like that, right? 2000 hertz. And if I add the host thing again, then there's no other podcast by Roman Mars in this database, right? So, but for instance, if we took, let's say, one of our populist here, let's say we would take American Scientist podcast here, right? I could actually see what is similar to the American Scientist podcast in terms of, okay, there's Science Talk, Scientific Odyssey, New Scientist Weekly, and so on. So they, I would say basically based on shared but there don't seem to be shared hosts
No.
as such. Hosts P1 and host P2. So the host thing doesn't seem to be so useful. But you see, there's like, so some overlap in like the basic things, some overlap a lot in topics as such, right? So there's also other different levels of overlaps, basically, right? So physics, astronomy, science seem to be the default overlap, more or less. But then there are other things like podcasting, education, ethics, and so on. So if you take one from that you're interested in, Alex, so if you go back to where's here this? Do you have one that we can find quickly? Play FM in search.
Last time we looked at the Naked Scientist, so we had
Exactly. So
we had that open.
yeah. So we have where's our query here? So that's probably similar to oh, Omega Tau, nice. Fancy Lab Code Guild, Science Podcast Daily Edition, self-helpful. Oxford Sparks.
Big questions. Huh?
Recommendation based on tags at least works. I'm not sure if there's another. Why does it always return remove my end? No. But we had the relationship between host and podcast is from and hosts the podcast, right? No.
Yeah.
So my
I
expression
think
and
they
host
are probably
hosts the podcast and host the second podcast.
maybe
And
there aren't
exists. But that's unfortunate somehow, right? So
yeah.
So that also would mean that we have no hosts that have more than one podcast. That's also interesting, right? Return host and what the degree is. Or we can probably say just host P. As degree and collect P. Order by degree. Descending limit 10. There are some hosts that have 82 podcasts. But that's then
Okay.
BBC something. So it seemed to be in the data, but somehow somehow it's not the ones that we looked at. Right. So there seem to be some that have
yeah. Okay.
quite a
More
lot,
like
right?
studios. Yeah. Okay. Less people. But yeah.
But then, yeah, exactly. So I don't think it's individuals. It's more like the studios, and then they probably don't have so much overlap, I guess. Right. So there's one person, right? But
Here's one,
or another one.
J,
But they're probably not doing the science podcasts then, right? Or I mean, we could look at Ofra, what podcast she has, right? Where and then okay. And we would say also get the podcast. And then we could basically Super Soul Masterclass. So Super Soul is probably double entry because of the different,
The slugs, yeah.
not
Maybe they
unique
changed something at
slugs.
some point or something.
And
Whatever.
then the
yeah.
master class is basically.
Yeah.
So if we took in our recommendation here the master class and looked at this, then we should actually get something for as a recommendation as well, right? Of course, it's then just the super soul, but we see actually that so if the data provides host information, then we actually get something back, right? So I just wanted to make sure that this actually works, right? So if you had more hoster data and guest data, that would be also really interesting. So I would really love to see kind of how guests basically are taking the rounds in certain podcasts. And you could even probably see if someone is publishing a book or a movie or something like that, they probably do rounds in a lot of podcasts, basically promoting that book or that whatever they published. And so you would actually see them appearing suddenly in a lot of podcasts in a certain time frame as well, right? And that's another thing that
vice
you could
versa,
look
I
at.
guess you often see if somebody is a guest at another podcaster, they are also guests at their podcast. Usually they
They cross
each hosts
over.
a
Yeah, that's
podcast,
true.
but then
Yeah,
they
yeah,
visit
that's
each other
true.
basically as
Yeah,
an exchange. Yeah,
exactly. That's true. So this is some more that we can do with this data, and I'll actually I think it's quite a nice data set. So probably we import a little bit more data into this, and then we can perhaps publish it as a Neo4j data set. That would be nice. And we have to clean out the slug duplications, right, and the ID duplications. So this has 299, 8315, and this has a different ID, for instance, right? So
I was thinking maybe this could be because some podcasts have seasons. So season
it
one,
could
season
be
two,
that it's different seasons of the same podcast. Yeah, that could be. So it could be that one is kind of the general entry, basically, right? And then one is basically then just one season of it or something like that. So that's something that we probably need to look into a little bit more detail. But for instance, episode count for both here is the same, right? 403.
Yeah, then this can't be the season.
Which is interesting, right?
Yeah, then there's maybe some.
But that these IDs then are duplicate or different, that's kind of not okay, right? So you would at least expect something to be unique about them, right? And perhaps you just need to strip the trailing number from the podcast slug or something like that, if it has a trailing number. I mean, sometimes it might lead to incorrect removal, but at least if it's an like 6-digit number or whatever, we can probably merge them together or something like that. As such, right? Cool. Sounds good. Okay, I think that's it for today, Alex.
Yes.
That's what we wanted to show, right?
Exactly. That was very good.
Yeah, this was fun.
Definitely, it's a cool data set, like you said, and I think it's very interesting and worthwhile to look at it. In each, we explored it a little bit. We showed a few things, so I think that was very good. And thank you all for watching. Tomorrow I'll be back with a Neo4j live stream, and I have the guest that was supposed to come on a couple of weeks ago, but we had technical issues. But tomorrow we'll talk about graphics, which is an Alteryx connector for Neo4j. So Thomas Larsen and I will do that tomorrow afternoon. So if you're interested in that, join us then. Until then, see you and have a good rest of your week. Take care, everybody, and and enjoy the week. And don't forget to submit to notes. Bye.
See you soon. Take care.